Welcome to CE 402 Environmental Engineering 2 Module 4 Part 3. In this session, I am going to discuss about the intermittent sand filters, which is a type of filters used in wastewater treatment plants. This is the form of a biological sewage treatment unit used in earlier times. And it is also known as land filtration because there is no lining of concrete is used inside the filtration tank. It consists of a rectangular tank with a specifically prepared bed of sand. As the name suggests, it is a sand filter. Now it is rarely used because the area requirement for constructing this intermittent sand filter is huge. Then contact media used here is the finer sand, which is very finer compared to the contact beds. And there is no concrete lining around the filter media, as in the case of contact beds. Then the sewage is purified by the following two actions. First one is mechanical straining. Then second one is the bacteriological activities. Then the sewage is applied to the filter media on a regular basis, and the air is trapped at the interstices of this filtration media. And when this dose of sewage enters into these small pockets, that is interstices, and the aerobic bacteria also enters into these pockets, and which will cause the oxidation of the organic matter present at small void spaces between the filter media. Then during the filtration, organic solids get arrested in the sand voids due to the straining action and get removed. This will act as a strainer, and this organic matter present in the wastewater will strained and captured in the small void spaces present in the filter media, and the cleared water, filtered water will be collected at the under drainage system. Then after percolation of this sewage, filter media is given some rest before supplying next dose of sewage. This is provided for entering the atmospheric oxygen into the filter media so as to accelerate the oxidation process of the organic matter which is captured inside the voids of the filtration media. This is the schematic representation of these intermittent sand filters, same as that of the contact beds. There will be a dosing tank which a siphon pipe is connected from the dosing tank to the filtration tank. And this filtration tank is constructed below the ground level, and the filtration media is provided. You can see the filtration media. The topmost part of the filtration media will be filled with the finer sand, and the bottommost will be comparatively coarser sand as used as the filtration media. Below the this coarser type of sand, the under drainage system is constructed to collect this filtered water to the outlet pipe. And you can see the distributor pipes as in the case of contact beds, same as that of in contact beds. This distribution pipe system are used for distributing the wastewater evenly on the surface of the filtration bed. There are five parts of intermittent sands are there. That is first one dosing tank, second one distribution pipes, then sand bed, then gravel bed, and then under drains. Next is the construction. The construction of these intermittent sand filters done by excavating the earth, and it is without any lining on the sides or the bottom. There is no concrete lining is used at the bottom or sides of the filtration tank. The tank is about 1 to 1.25 meters deep and having an area, surface area about 1000 to 4000 meters square. And the length to length to width ratio is about 3 to 4. The filtration media, that is the filtering media, is always sand and having an effective size of zero point 0.2 to zero point 0.5 and a uniformity coefficient as 2 to 5. The sand is filled in the tank and the sand bed of depth about 0.75 to 1 meter is prepared. Then below the sand bed, the bed of gravel of thickness about 0.15 to 0.3 meter is provided in order to facilitate the drainage of the effluent and collecting this drained water into the drainage pipelines. To carry off the drain pipes, open jointed drain pipes are laid in the gravel bed. And usually 3 to 4 beds are provided adjacent to each other so that they can work in rotation. Because this is not a continuous operation as in the case of rapid sand filters or in the case of trickling filters, it is an intermittent operation. Bottom of the tank is made of slopings gently towards the drain pipes, that is under drains, and which are placed at about 9 meter apart in trenches below the bottom of the sand filtration media. Then the under drains, the vitrified tile pipes with open joints of about 1 centimeter is taken as under drains. The under drains are surrounded by gravel to carry the effluent, and it will help to enter this effluent water into the under drainage pipes. The effluent is applied by means of dosing tank and siphon arrangement as it already shown in the schematic representation, and then flows into the trough laid on the filter bed, and to serve 3 to 4 filter bed at a regular basis intermittently, manual valves are used. Then the troughs have side openings which allow the sewage to flow on the sand bed. The sewage from dosing pipes are spread intermittently over the filter bed using distribution pipe laid above the sand bed. These pipes are laid about 9 to 18 meter apart. A number of outlets should be provided on these pipes so that the sewage may distributed evenly over the sand beds. Then the sewage effluent from the primary settling tank is applied intermittently on each bed through this dosing tank provided with a siphon. And the flooding is provided only up to 50 to 100 above the filtration bed. And during the period of sewage remains standing on the filter bed, it gradually percolates into the filter media. And the sewage percolation through the filter bed, the suspended organic matter present in the sewage will get trapped into the void spaces of the top portion of the sand bed. And thus the organic matter is first removed by the straining action, that is a mechanical straining action of the filter. Then after the entire quantity of applied sewage is percolated down, that is strained down, the filter bed is kept rest for some time before the sewage is again applied. During this rest period, the trapped organic matter is acted by the atmospheric oxygen, that is in the presence of aerobic bacteria. It will oxidize the organic matter into stable compounds and gases. And after 24 hours, the sewage is now applied over the second bed, while the first bed rests for 3 to 4 work in rotation. During the resting period, the dried sewage is scraped off. That is the topmost portion of the sand bed, that is the fine sand bed, is scraped off in order to avoid the clogging of the topmost portion of the filter media. Then the hydraulic loading rate is 80 to 110 liters per day per meter square of plan area of the filter bed. Then the effluent from the intermittent sand filter is quite clear, well nitrified and stable. The effluent can be disposed of without dilution because of its quality. And the effluent contains suspended solids less than 10 ppm and a BOD of less than 5 ppm. However, in order to maintain the efficiency of the filter, the topmost layer of depth of about 25 mm should be raked or scraped out at regular intervals to break up the materials caught in the top part of the filter, that is in order to avoid the clogging of the filter. The sand of the filter should also be renewed at a regular basis. Then the rate of filtration of an intermittent sand filter depends mainly on the three factors, that is depth and size of the filtering material, the nature of the influent, and the quality of the effluent required. Then the finer the sand particles, then the filtration rate will be very less, but the quality of the effluent will be high. Then coarser the sand, the filtration rate will be more, but the effluent quality will be less. So a combination of this fine plus coarse is used as the filtration bed. That is a 15 centimeter layer is kept fine, and a portion of this coarser sand also provided at the bottom part of this finer layer of sand particles. Then the advantages. The quality of effluent obtained from the intermittent sand filter is very clean and stable, and it generally does not require any further treatment before disposal except chlorination in some cases. This is the main advantage of intermittent sand filter. The less chances of anaerobic conditions to develop, so there were no trouble of odor, flies, etc. The operation is very simple, require no mechanical equipments except for dosing and for scraping this topmost layer of the filter bed. And a small head is required for applying the sewage on the surface of the filter, and there is no secondary sludge which is to be disposed of except for the occasional sand scraping, that is the topmost layer scraping. Then the disadvantages, the rate of filtration is very low, and hence that of loading is very small per unit surface area of the filter. Hence they cannot be employed for a medium or large sized wastewater treatment plants. They require large areas of land and large quantity of sand, on account of which their construction is very costly. I hope you understood the session about this intermittent sand filters. Thank you for listening. See you in the next class.